immensely in the software development, software engineering industry. They're kind of the unsung heroes, I would say, of a lot of modern software, a lot of software in general. Um, we don't really talk about them that much in undergrad. If you take possibly something based on constructing your own projects, probably like 418, I've heard, has a little bit of that mixed in. I've even seen it in 333 discussed a little bit. That's principles of programming language. Oh, sorry, 311. I don't know what I'm saying. Talked about a little bit for a chapter, but not too much. But in the industry, you'll start to see it a lot. So let's get into it before anything starts off. So let's go. Okay, so what are design patterns? Design patterns are used to represent some of the best practices adapted by experienced OOP software developers. So, a design pattern systematically names, motivates, and explains a general design that addresses a recurring design problem in OOP systems. It describes the problem, the solution, when to apply the solution, and its consequences. So, all right, what does that really mean? So, pretty much, I'd like to attribute that kind of to like a like a general solution that kind of, because we've had software developers, I'll even go back to, we had COBOL and everything before that, but let's say C, right? People were coding like programs, making software in C, and for the last like after years and years of doing that, you start to pick up these like little things that people do, similar ways to solve problems, and they're like, oh, okay, we can make something out of this. What is it? Why are we redesigning the wheel every time, or recreating the wheel when we don't have to? So they created these software design patterns. And pretty much you use these software design patterns when you're constructing software to make it simple to talk about, to make it simple to explain, simple to work with. And I would really attribute it as like a general kind of idea. And I think a good way to look at that is look at an architect or civil engineer, right? When they want to construct a building, they're not going to spend tons of time designing elementary parts that have already been created by other people or have been created so much there's no need to just spend your thought process on trying to create them. You're going to take those parts, put them together, and create something new. And that's what software developers do when they use software design patterns to make their applications. So let's move on to the. Oh, one more thing I want to say. Sorry. Software design patterns are programming language independent. Again, going to that generality aspect, and they show relationships between classes and objects that you might not be able or might not have seen or might not taken advantage of beforehand. So, what are the types of software design patterns? There are mainly three types of software design patterns. Those design patterns are creational, structural, and behavioral. So, before I move on into explaining a little bit more about those three classes of software design patterns, does anybody have any questions, real quick? If not, I'll just move forward. All right, it looks like we're okay here. All right, cool. So, I'll move forward. So, creational. Creational design patterns revolve around class instantiation or object creation. They help make a system independent of how its objects are created, composed, represented. Creational design patterns can actually be split up into two more subtypes, class creational and object creational. The main difference between the two is that class creational patterns use inheritance to vary the classes that are instantiated, or the class that's instantiated, while object creational patterns will delegate instantiation to other types. So let's get into a little bit more about that and talk about some creational pattern examples. So I know I have a bunch of definitions here. We'll get into a little bit of the the meat of this. So let's talk about something called abstract factory, right? Abstract factory design pattern creates an instance of several families of classes. The purpose of this design pattern is to provide an interface for creating families of related objects without specifying concrete classes. So if I were to think about that, I mean, if we read the definition, creates an instance of several families of classes. Think about inheritance first off, right? The whole problem of, oh, I have a bunch of these related objects, or I always think of like when I think of inheritance, I think of animal. and you go to create dog, cat, whatever else kind of animal, right? That are subclasses. Um, an abstract factory kind of provides a a system in which you can easily make these concrete classes that have like little variances. Factory method creates an instance of several derived classes. So the purpose of this one is to let a class defer instantiation to subclasses so they can decide which class to instantiate. So it's kind of an interesting thing here that what the factory method design pattern does is it will pretty much push that work off to the subclass or two subclasses to pretty much decide what kind of object it needs, and when it decides so, pretty much what object to create. The next one in the creational design patterns is the prototype, and a prototype is a fully initialized instance to be copied or cloned. Again, its purpose uses an instance of a class as a breeder for all future instances. So pretty much instead of, having to go through the process of, I guess, figuring out what you need and creating it over again, you kind of have this object set to the side, this kind of object's not really used to create different variations or to kind of just like put that object throughout the code when you need it, or throughout the software when you need it rather. And then a singleton is another creational design pattern. I'm pretty sure a lot of you guys have heard of singleton. I think if you've heard of software design patterns, you've probably heard of singleton. And if you haven't, you've probably used it to some kind of degree. But a class of which only a single instance can exist. And its purpose is that other than just, having one of it, it enforces that you have one of it, and it gives you pretty much global access to or access points to access shared resources from anywhere in the program. Any questions right now on these design patterns? Okay, then if not, let's keep moving. So a closer look at factory. So down here, I have some text. I have this diagram here. I think it's UML diagram. Yeah, that's what it's called. And it pretty much shows how the factory design pattern implementation would work. So let's read the text at the bottom. So factory pattern demo. The demo class will use shape factory to get a shape object. It will pass information, circle, rectangle, square to shape factory to get the type of object it needs. So factory pattern demo, our main class, is going to ask shape factory to get a shape with that method, and the method is going to pretty much get a certain type based on the input to create the object desired, right? Um, this is kind of an easier way because if I think about another way, right? I think a good thing or a good example of this that you might want to be wary of is using like I don't know, if statements to be like if this is something or else if this is something or like instance of kind of thing, like this is an instance of this, create an object called this. It kind of just makes the work a lot easier because you're like, oh, just get shape, put in your parameters, you get out the object you want. So again, yeah, if we look at the um, definition back here with factory method, so yeah, it pretty much describes that whole thing. Any question about the factory design pattern or the diagram here and what it's doing? All right, if not, I'll just keep going on. So, a closer look at singleton. So, this actually has to do, this diagram actually in particular has to do with a decent amount of object-oriented principles here. Um, think about it, right? When you had like a private constructor, I kind of thought about that when I saw this diagram here. But if you don't want, say, your user to be able to just make random, like random objects here and there, like if you're looking at like the program or something, you want to keep that. encapsulated within your program. You don't want that to leak out, right? Same thing with a singleton object. That's really important. You don't want the object, the one object that you're supposed to have, trying to be created here and there. So it does a pretty interesting thing. So singleton will call its accessor method. We'll call it a main, I guess right now, and it'll go into single object. It'll call get instance, which is what they named this for the single object class, and it'll return it. And the logic behind the singleton class is pretty much says, oh, uh, is like an object of whatever the singleton type is, does that equal null right now? If it does, instantiate a new one and send it. If not, just return whatever you have. Return that object. So text right here, or single object class provides a static method to get its static instance globally. Pretty much, if you were to have that in Java terms, you would have a private member of the singleton object that's static. So it's just one for each object, and it could just be accessed pretty much throughout the program. So yeah, single pattern demo uses the demo class or uses the single object class to get a single object. I know that's a little repetitive, so but that's how they name their classes for this diagram. An example I think you'd see in, or at least I've heard of, which makes a lot of sense, is if you have like a big database, right? So think about, I don't know, a big company that has like a huge database, like maybe Amazon or something, and they want to have a bunch of clients or workers pretty much connecting to the database. They're not going to spend a lot of time or a lot of they're not going to make a bunch of objects to pretty much be links to the database, right? They're going to have one singleton object that pretty much takes all those requests, put them through. You can access the database and go in and out from there. It's just, to make a bunch of objects, there's no point. It just muddies up the program. It just muddies up everything. You have a bunch of objects you don't need. And also it's just very expensive because it's just like, why do I have these here? I don't need these here. And you're just wasting space. And you're just wasting processing power. So any question about the singleton object? Anything else you want me to go over right now? Are you okay? All right, cool. So a nice little recap of creational software design patterns. Pretty much, yeah, they revolve around how objects are created, how they're instantiated, and pretty much give you good ways in different situations to apply, um, best practices of how you can create objects, how you can instantiate them. So now that we've covered creational, let's move on to structural. Structural design patterns revolve around organizing different classes and objects to form larger structures and to provide new functionalities. So they're used to ease the design process by identifying a simple way to realize relationships between entities. And when I say entities, I mean object instances, classes, whatever other structures you might have. Um, Structured design patterns explain how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. So I think a big problem, I mean, it is a big problem, but we might have not seen it at the university level as much because I think a lot of our work is really kind of just developing our coding skills, not really building like huge applications that involve a lot of work in them. But once you get a really big application right, um, if you don't have a good structure, it's gonna be extremely hard to try to edit things, and I'm sure if you built any kind of sizable application and you've edited one thing without really giving too much thought about it, you got so many syntax errors or whatever language if it's interpreted, probably runtime error, I don't know, something like that. Something is not going to work, and you're gonna have a horrible time debugging it. Having a good structure and being able to change things flexibly and efficiently really helps and really saves you a lot of time. So, without further ado, let's get into structural. So some structural pattern examples. We have the adapter software design pattern. which matches interfaces of different classes. So the purpose of that is it allows objects with incompatible interfaces to collaborate with one another. Something that you would otherwise probably, I mean, to think off the top of my head, you probably have to do a lot of legwork just to have that really happen since they're just kind of unrelated. If you have that in place, really helps out a lot. Cleans up a lot of, or rather, doesn't clean up, but it makes you avoid a lot of just unneeded strategy when it comes to making those objects collaborate. Bridge. The bridge design pattern separates an object's interface from its implementation. So the purpose of a bridge, it allows one to separate similar classes into separate hierarchies. I've also seen it said as if you're working on one big class, right, or something that's really large as well, you can split it up into separate hierarchies as well. This could definitely help if, for example, there are little things and little implementations that have to do with similar classes that you might want to zone in on. A bridge could really help with that. Composite. Composite is one I actually like. This is actually interesting too. Um, a good deal, actually. A tree structure of simple and composite objects. And the purpose of this design pattern is it allows one to work with structures within the tree as if they were individual structures. So pretty much imagine, think of any kind of tree you want. I don't know, think of a red, black, binary, whatever you want, right? You have this tree of these, you know, um, you know, could be large size structures or whatever, and you want them grouped together, but you want to look at them independently when you want. So you could do that with implementing the composite design pattern. And lastly, for this slide, decorator, which adds responsibilities to objects dynamically. And the purpose of this is allows one to attach new behaviors to objects when needed without explicit addition. So I like this one a lot too because it kind of gives you a sense of, oh, while the software is running, while it's, I don't have to sit down and explicitly say, okay, I want this feature added. I want this to do this. I want this to do that. It kind of sees what it needs due to this decorator design pattern put in place and says, oh, hey, if I need this, I'm gonna attach this new behavior so it can actually accomplish what I want it to accomplish rather than me having to sit down and think of every kind of possible case. And sometimes it might not even be worth it to have them all in there at once because it just muddies up the class structure or the object structure. So, any questions on these design patterns, these structural design patterns, or maybe structural patterns at all, or anything else you might want to ask? Okay, if not, I'll keep going. So, a closer look at bridge. This is the diagram, the UML diagram for the bridge design pattern. It's a little complicated, at least I think it's a little more complicated than the rest, but if you break it down, you can kind of see how it works. So we have the draw API interface, which is acting as a bridge implementer, and we have concrete classes, red circle and green circle, implementing that draw API interface. Shape is an abstract class, and we'll use object of draw API. So pretty much, as you can see here, we have these two pretty similar classes, red circle and green circle, with just very like minute differences, but we still want to be able to use them and work on them, individually, right? So we have this bridge pattern. So pretty much what the bridge pattern will do is enable us to pretty much isolate red circle and green circle and pretty much enable us to, go down and look at them rather than just kind of have them all like interconnected just because, oh, they're all technically circles, but I might want to look at them differently. So that's kind of how that one goes. I'm trying to think of a good example of this one in Modern software. Trying to think. Um, I could possibly see this, like, maybe if you have, like, objects, although probably more of a database kind of thing. But if you had, like, maybe for perspective, right, maybe think of, um, like, user accounts for an application, right? They're all, like, applications, or maybe you can even go down further and say, like, "Oh, applications in Albany," or something, right? Like, user accounts in Albany. They're all similar in that respect, but you still wanna go down, and you can break them up with something like a bridge. Okay, so the next one is closer look at Decorator. So again, going back to what Decorator is, Decorator adds responsibilities to objects dynamically, meaning while the program runs, it'll, add responsibilities when needed. So in this diagram, we're creating a shape interface and concrete classes implementing the shape interface. We then create an abstract decorator class, shape decorator, implementing the shape interface and having shape object as its instance variable. So red shape decorator is the concrete class implementing shape decorator, and decorator pattern demo or demo class will use red shape decorator to decorate shape objects. So pretty much, if we look at this decorator pattern here, this diagram, we have the main method, or the main method in the decorator pattern demo class, asking shape decorator to calling the um, shape decorator constructor, or and pretty much it'll decorate the shape we have right over here, and it'll pretty much draw a circle or rectangle, shape being the interfaces that circle and rectangle implement. So also, yeah, the red shape decorator down here, which gives it the set red border. So if you want to change between border styles or border colors, that's how you would do that. Uh, any questions about the decorator design pattern? Okay, I'll keep moving. So that's pretty much what we're talking about for structural design patterns, and pretty much going back to structural design patterns again, relationships between objects, entities, really structures, classes, etc. And by using these design patterns, you can make your software much more flexible and efficient. So now behavioral, which is the last type of software design pattern. So behavioral design patterns are all about identifying common communication patterns between objects and realizing what these patterns are. Behavioral design patterns are concerned with the assignment of responsibilities between objects, or encoding behavior in an object and delegating requests to it. Behavioral design patterns also increase flexibility in carrying out communication between different components of software. So, pretty much, for laid out from here, behavioral design patterns are all about communication between objects. And, um, if you think about that, for example, which it covers here, if you might have some questions regarding, well, you know, um, maybe I want two totally different objects to connect, right, or to communicate. What would I do in that instance? Or what else I have, like, two similar objects, or this and that? And you get all these questions. Behavioral design patterns kind of have you covered there. So again, we have some examples of the software design pattern, the behavioral design pattern. So here, the first one, we have chain of responsibility. So the chain of responsibility is a way of passing a request between a chain of objects. And its purpose is that objects that can handle a request at the current moment can choose to process or hand it off to the next object in the chain. I think a good example of this would be probably if you had some kind of um, task that had to be done by a certain part of your program, right? And you have this chain of command, and you kind of just pass the task down. And you want it to be done by somebody, um, and maybe one part of the program is busy, so it'll just pass on to the next, pass on to the next. Another way is actually looking at it like that, and just being like, well, I don't know who this has to be processed by, but I have this hierarchy of objects. I'm just going to pass it down, and eventually we'll get to the right person or the right object, right? So that's the chain of responsibility there. Iterator. I know if you've ever done any. Well, I shouldn't say that, but if I think 213 covers this a little bit too. Allows one to traverse elements of a collection without exposing underlying implementation. You've probably used the built-in iterator class and iterator object to create your own iterator object in Java if that was the language that you worked in or
That
that
was
you.
literally this week.
Yeah. Yeah, so you guys definitely have, experience with iterators, right? So the iterator is actually a design pattern. So, the cool thing about iterators, at least from a developer side, is that it allows the client to use that iterating functionality going over a collection, right? Without needing to know the underlying data structure or even how it works. So, say I want, maybe someone's using Spotify, right? And for some reason, I have their, 500,000 songs in their, playlist or something. They put a bunch of stuff in there, in some kind of like, let's say let's just say a binary tree, right? They don't know what a binary tree is. They don't even know how that works, right? But they can just iterate all through those songs all that they want with an iterator because they don't have to care. They don't have to know, and they'll never know unless they specifically try to look or try to go in computer science because that's how well it's encapsulated. So that's what makes iterator a really good software design pattern. So mediator, this is another good one too. Defines simple communication between objects. And its purpose is rather than having objects communicate directly, which can introduce a lot of chaotic dependencies, pretty much meaning like, I have a connection between object, if I have like, say I have like thousands of objects, if I have all of them communicating with one another, that's going to be a big number, right? I don't want that. If I could have all of those objects when they want to communicate with another object, communicate with a mediator object instead, I eliminate a lot of those dependencies, and my code does not get polluted by pretty much all of these connections to different objects all over the place. So the last one here is going to be visitor. So visitor allows one to define a new operation without changing the classes of elements on which it operates. So the purpose of this one is it allows distinct and unrelated operations to be performed on objects without polluting the structure of the classes in which the objects are defined. So I think a good example of this is say you have your class structure for an object, right? Let's just I don't know, call it a node because that's just an easy thing to call call an object in a huge structure, right? In a huge in a huge project, and I want to be able to manipulate the structure in this way, but I'm not gonna go ahead and put that into the class like the blueprint because well then I'm gonna have to what happens if I wanted to do something else another day or something else another second rather, right? I'm gonna have to go in there and literally pretty much pollute my class structure with all of these like unnecessary properties and methods. It's just it's not it just make it look disgusting. So the way you'd use that is you use a visitor, which pretty much enables an operation to take place on an object or with an object without explicitly defining it or attaching it, I would say, to that class structure of the object. Any questions about behavioral patterns or these behavioral patterns
Can
or anything at
can you
all?
give an example of this?
A visitor?
Yeah, of a visitor.
I think I might have an example of visitor, but let me think actually. right now, if I wanted to think of an example of visitor. So actually, I could think of principles of programming languages 311. Pretty much, we had a. This gets into a little more stuff. This is exactly where he had said, Professor Phipps had said, use a visitor pattern, which we didn't end up using. But when I saw that, I thought it was funny. We have this structure pretty much called an abstract syntax tree, which you don't need to know what that means. Pretty much just it's a list of just we'll call them nodes right now. It doesn't really matter. But pretty much we wanted to do things to those nodes that weren't built into its class structure, right? So instead of defining the operations for one of those each one of those node classes, right? Those node objects, because they're different nodes. I'm just calling them nodes because I'm not going to go ahead and say all these different random object names. We used, or we were supposed to use a visitor pattern to go through and do all that. It turns out for what we did, we were actually just able to use for loops. But if it was more complex or we had to use a visitor pattern, we would have used it in that sense. Does that explain it a little bit more? I know it's a little bit of a little more advanced terminology, but
Yeah, yeah. No, that clears it up a little
yeah,
bit.
it's pretty much you don't want to pollute your or you don't want to just put like if I have a I don't know, like a square object, right? An object for a square. I don't want to put like a calculate, you know, 10 different times 10 different types of equations like as instance methods, right? I might want to try to do something where, if I have a whole thing of shapes, I might want to be like, oh, I want to calculate its, area or, the length of its sides if it has any or something like that. I'm not going to just put that in there just automatically. So it just kind of visits, sees if it can do an operation, and then goes, keeps going. So, any other questions right now, or are we okay? All right, so let's keep going. A closer look at chain of responsibility. So, this is actually a good one because this diagram actually kind of holds a real life scenario. If you have some kind of a logger, right? Like you'd use to just keep a history of what your program is doing or what I know in if you're making changes to like a database, for example, you want to log those changes. So if something happens, you want to be able to see like what did we do beforehand? Did anything get interrupted? Right? You want to be able to check that. So this kind of illustrates a good chain of responsibility for a logger. So we have created an abstract class, abstract logger, with a level of logging. Then we have created three types of loggers extending the abstract logger, file logger, error logger, and console logger, respectively. Each logger checks the level of message to its level and prints accordingly. Otherwise, it does not print and passes the message to its next logger. So pretty much the chain pattern demo there, which is the class, pretty much call abstract logger, and it'll pretty much have this message or write this message, and it'll say, "Hey, can any of you guys take care of this message?" And the chain of command, they'd be like, "Oh, well, this is not my message to take care of. It's not my type. I'll send it down to maybe a lower to lower derived class, or maybe just send it to another class in the chain of command that's I'm not connected to, but connected in a way that it's in the chain of command." So that's kind of how it works here. So like if I had something, maybe I created a new file, I'd send it to the file logger, but if it started out and it was given to the console logger, I don't want to put that. I don't want to give it to the console logger. It'll give it to the error logger. I don't want to give that to the error logger. I'll give it to the file logger. That's where it belongs, right? So that's kind of chain of responsibility in a nutshell there. So yeah, that's kind of a good example. Loggers are definitely, especially if like you're working, especially like what I said before with the database. If your power goes out and your server is not online and you were in the middle of making changes to your database, what am I going to do? I need something that kind of gives me my history of what I was doing. And, it's a good example. Use chain responsibility for that logger that you'd have there. Okay, so a closer look at Mediator now. As I said, Mediator before was this kind of object that other objects would talk to connect to other objects. So this example is an example of creating a mediator for a chat room where multiple users can send messages to the chat room, and the chat room's responsibility is to show the messages to all users. So actually, something like Discord, right? You probably would have a mediator pattern when you want to post in something like, say announcements. Like when I send an announcement, instead of talking directly to all of you, say through DMs, it's gonna send it to that mediator object, and that's gonna send it to all of you guys on the announcement page. Again, I don't know if that's exactly how it works, but do you get the idea of how that kind of works? I'm not sending that to you all directly saying, "Hey, we're having a workshop tonight," in your DMs. That's not happening. It's going to the announcements page, and then you guys can all see it. So that's kinda how, Mediator works. I could definitely see Mediator being used for a lot of other things. Trying to think too. Definitely a good point of it would be to message like some kind of message board. But yeah, and I definitely like think about if we had, you know, if I wanted to announce, oh, we're having our workshop tonight at 8, or I sent every little thing that happened in announcements or any chat, and it went to you all like directly. Just cause so much clutter and so much extra processes are going on that don't need to. So implementing Mediator there is definitely a good choice, a good design pattern to implement for that kind of problem. Any questions so far at this point about Mediator, about any of the software design patterns so far that we talked about, creational, structural, behavioral, anything you want me to go back to, free to do that. Just any questions whatsoever? No? Okay. So I'm going to
Oh,
move on.
oh,
Yep.
sorry, am I too late?
No, it's fine. Don't worry.
Uh, could uh, I'm still a little lost about the decorator one, like the
Yes.
example with the shapes. Uh,
So we can
I
go back
just
to
wasn't sure what exactly was being decorated. What you said like a behavior was being added to the class, but I wasn't really understanding what.
yeah, I could try to even explain it a little better, maybe with an example, right? So let me go back to decorator in the first place because I do that pretty easily. Here we go. So yeah, this one was a little more complicated, but pretty much as we said before, if we go back to the actual definition of decorator, it adds responsibilities to objects dynamically, right? So let me use another example that might be a little bit simpler to digest. Or a bit easier to explain on my end to digest. Say in a video game, right? Um, Maybe I have like an enemy or something that can only like, shoot and run, right? Or maybe shoot and walk. Let's put a better thing, right? And when I start up the game, or when I start up that part of the program or the game, that's all I needed to do. What a decorator would do, say if it needed to like run or it needed to have the ability to speak, the decorator would pretty much give it the functionality dynamically. And dynamically pretty much just means while it's running. I don't have to explicitly say, hey, give it this functionality, while I'm coding it. I could pretty much have my structure be like, oh, it needs this functionality. Let's go give it to him via decorator. Does that make a little more sense?
Yeah, I think so.
Yeah. It is a little bit of a more complicated aspect, and me myself, I'm just starting to learn a bit more about software design patterns, so that's my rough interpretation of it. So, of course, this is all learning experience for all of us. But John, do you have a question or no?
I was just gonna say, um, I understand the concept. I just feel like that's something that's too good to be true, and if it's not too good to be true, then it must be really complicated to even just implement.
Well, the whole idea of that, right, is in order for something like that too good to be true, right? You have to have a really good project structure, a really good program structure, where that your program will get to a point and say, "Hey, this object needs this functionality. We're going to give it this functionality via some method or via some process." Or maybe we'll make a new object and have it do something like that. it pretty much the software design patterns, what underlies all of this is really making a good project structure so that you can implement these and all of these can work effectively and efficiently. So it does seem a little bit too good to be true, right? Because we're all used to implementing things by hand and whatnot. And if you really get these uh, ideas eh, more in like a general term of, oh, software design patterns really just make my code structure better, and I can work to make my code structure better so I can implement software design patterns better. You're kind of just you're working better. You're thinking more of like a software architect, how they want their projects really be set up so they work this dynamic way. If that makes sense. It's pretty much is hard. It's not easy, right? If it was easy, everybody would be doing it everywhere. But people work at this, and software architectures and architects. I mean, and
With
designers
that,
and everyone.
sorry, like, can you also think of an example of like a modern software design that implements something like this?
Like a decorator?
Yeah.
Okay, trying to think. Well, I thought yeah, so, like I was saying before, if you had like an enemy, like, in a video game, I guess that would be a good example, like, say, like, Call of Duty or something, right? Or, like, any video game. I'm not a huge gamer, I'm not gonna lie, but, say you pretty much need to attach another functionality, to an object, which you can think of as, maybe like a person, right? Or I guess a person is the easiest one because, obviously in real life people can learn new things. So if I wanted someone in the background, like an NPC, just to be walking around, that's pretty much I'm not going to have them give them the functionality to speak, right? But if it comes to the point where, oh, you're in this radius for them to speak, or you try to initiate some kind of other, conversation, or you might try to initiate another process, I might use a decorator to give them the ability to maybe, have some kind of like dialogue or something like that. Maybe probably generic dialogue or something. Like you'd hear something. Again, I'm not a game designer, so I can't say for sure. This is just a way that I think they might implement it. They might give them the implementation to say like some pre-written flavor text or something.
So, in an example like that, so if let's say, like if speaking was a method or would have been a method, instead of it being a native method in that class, it uses that method through a different class. Is that sort of what's
It
happening?
it pretty much gives it that functionality dynamically, so
Hmm.
that instead of having it be written like if I had a person and I wanted them to, I don't know, for the most part, just be able to walk in the background. If I just started putting like, "Oh, I want them to, walk in the background, but I also want them to read, write, do this, do that," right? I'm gonna muddy up my class structure. What the decorator really does is just says, "Oh, it needs this at this given time. All right, just give it to it. Give it to the object." You know what I mean?
I think so.
Yeah. Again, I'm not an expert on this, but trying to give a decent explanation of it. But again, yes, that's the main point of it. Internals of it, I think it uses a class wrapper to actually give it that functionality. But again, this is really just kind of an introduction to software design patterns. I honestly don't even think, unless you're going into the industry, tomorrow, you're gonna need, you're not gonna need to memorize any of these. It's just good to know that they exist, right? That's really the main thing about design patterns at this stage in the game. Once you get into industry, you'll be talking about these kinds of. You'll be talking with other developers about these kinds of things. James, I thought I saw that you wanted to say something quick.
Yeah, Decorator is actually really cool. This is actually the thing that I feel like makes Decorator so powerful is the fact that you have the ability here to dynamically add methods to pre-existing classes without having to rewrite the entire class structure. So this is one of the mistakes that I used to make when I was doing game engines. I would have it so I would have an entity top level class that would be like every single living thing, right? And I mean, you can think about like Minecraft as well, right? You have entities like falling sand and stuff like that, which it doesn't necessarily have a health bar, but then you have living entities, and the way that you normally implement that is just a big inheritance chain. A living entity is an entity, zombie is a living entity if it has health and stuff like that. But say you have something where you have a large chain of those, that's going to be really inefficient. It's much better to have a general entity and then use a decorator to implement your extra functionality rather than have a huge chain of inheritance for your classes. And then if things start splitting up into multiple classes and it starts becoming a tree, things are going to go downhill very fast. Decorators are going to be able to help you clean up that code a lot and make things a lot more streamlined and easy to edit, because you have the ability to break things very easily when you start getting massive chains of inheritance. So that's what
Yeah.
I think. That's why I think Decorator looks like such a powerful pattern. And I'm embarrassed to say that I've never actually used it. And I think this is really cool. And I think I'd like to use Decorator a bit more in the future.
Yeah, that's definitely a good point, James, as well. Especially, I know in languages like Java, and I think C sharp, which I usually put really akin to Java, right? You don't have the ability to use double inheritance. You have to kind of go around and use an interface, and that might actually be a good thing because in like C++ plus plus or whatnot, for if you want to kind of go off the handle and do some double inheritance and all this kind of stuff, and you pretty much do that everywhere to have these kinds of functionalities that Decorator would give you. Think about that. You now have like 2 or 3 to the n dependencies pretty much in your inheritance structure because everything's just inheriting from one or another classes, and it's just like, oh boy. And that would definitely make your code a lot harder to debug and understand. So yeah, that's why Decorator, I also see Decorator as very a very good way just to kind of like, oh, you need it, here you go, kind of thing. All right, any other questions at this point? All right, if not, I'll keep moving on. So we covered these already. This is the logger again. Closer look at Mediator. So now that you know about design patterns, should I use them everywhere? And I just put, I'm not gonna put a meme there because I don't want to look back at this and just cringe. But no, you don't. Um, the key is knowing that they exist, and when you're a developer, if you want to be a developer, when you are noticing when they're gonna benefit you. So it's important to note that before you knew about any software design patterns, you were writing code this whole time just fine. If you're a computer science student, you've done all of your assignments. If you're writing anything, you've written it okay. You don't need to go back and be, I have to implement this pattern, this pattern, that pattern, that pattern. You know they exist and you know they can help you. That's the best thing. Software design patterns, in addition, are based upon how developers normally would write code. So after years and years, like I was saying in the beginning, they were like, "Oh, we're noticing patterns that people do when they're solving, related problems. Let's make software design patterns." It's based off of what people normally did. So if we got rid of the whole concept of software design patterns, a couple of years from now, people kept coding and making, software without this whole idea, we'd probably stumble upon it again because that's just how people normally do things. They'll just pick up patterns. I think it's pretty interesting too because, as time goes along, time more and more, you run into other problems. You can create more patterns, which is interesting, right? It just keeps growing. Um, I think this is a good way to look at it. This is how I was told when I first learned about software design patterns. If you're working on like a software project and you run into a complex problem or have written something that's like just totally ununderstandable and you're just trying to solve some kind of like rudimentary, kind of like like easy to you thought it would be easy to solve problem or easy to do problem, there's probably a design pattern for it. Because if it's something that comes along, like say in a video game, you want to implement some basic physics or something, there's probably a way to do that, right? So if you're trying to do something else or something related to that, in code, it's probably a pattern that people have done. If not a pattern, at least something on Stack Overflow that you could use. So again, don't try to rebuild the recreate the wheel there. Don't use all your thought process on that. So in conclusion, implementing software design patterns gives developers a way to create software efficiently. Number one, which is just really an important thing, right? Because if you're a developer or you're a boss hiring developers, you want software to be made well and quickly. Um, you don't want people spending their whole time being like, "Oh, how do I make my own?" How do I come up with a new way to do to do the function use the functionality of Iterator? It's like, no, you don't. You just it exists. Just use it. Um, it also gives them the ability to talk to one another with a vocabulary that might sound esoteric to people listening in, but if I come to somebody, another developer, and I start talking about, well, this is what I did with line one, and I go all the way to line like 2098, they're gonna be like, dude, I'm not gonna follow all this. But if I start talking about like, oh, I implemented a visitor pattern here, and you see I just wanted to avoid inheritance here, so I used this design pattern, and they start to see that more, and they can talk back to me and give me more better feedback. Um, Also, the last thing I want to say too, these ideas are general. They're not akin to any specific programming language. Patterns themselves are pretty general themselves. So it's like, um, you can apply this kind of thinking to anything that you're building. Like I was saying in the beginning, civil engineers, architects, when they build a building, they get a rough thought for or a rough outline for specific things they want to implement. They're not going to, start thinking about how to, redesign a roof or design a roof. That's, their own idea concretely. Just like you're not going to spend time trying to, solve a problem that's been solved a million times. So that's it for this workshop tonight. If you guys have any questions, I'm going to stay here for a bit and answer any questions. We could even do some research if you want to know more about software design patterns. Yeah, if you want to head out though, feel free. Well, James might actually want to say something to the group before we get out. But yeah, thank you for attending. I appreciate you guys listening, and have a great night, guys.
Thank you, Matt. That was a great workshop. I thought that was a lot of valuable information. Software design patterns, that's 100% right. Really undervalued, especially here at SUNY Albany. They do not teach you this, but software design patterns is really the macro level of computer programming. What we do on Monday nights is really algorithmic design, which is like the micro scale computer programming, and that can get you really far, especially when you're not doing massive projects. But if you really want to go into industry and become like team leader and someone who's actually running these large scale software projects, then you're most likely going to have to learn and master your software design patterns, because that's really where all the money is. No one's paying you to implement Quicksort. They're paying you to come up with the big grand scheme for data flow throughout your application, and you're doing all of that in with these software design patterns. So again, it's unfortunate. It's not a topic that's heavily touched on here at UAlbany. The closest you can get is 418, and personally, I don't think 418 does a very good job at teaching you software design patterns. It's going to depend on who's teaching the class, but when I took it, it was kind of abysmal. But if this kind of stuff interests you, I would say 418 is definitely a good class to take, but get ready to read the textbook, because you're probably not going to learn much in the class. On top of that, all right, so with that, again, thank you, Matt. Great workshop. But in terms of things going on, tomorrow night we're going to have side project development night. After side project development night, talking about next week, we're going to have interview prep, professional development night on Monday night. Then Tuesday, we're going to have a mandatory officer meeting. I believe it's Thursday is Matt Chung's workshop. Is Matt in this call?
What's up? Yeah, it's Thursday.
Workshop,
Yeah.
briefly.
Oh, you want me to talk about it?
Yeah.
Yeah, we'll be. It's an intro to creating a Discord bot. It's it's pretty straightforward. Everyone should walk away with a functioning one, and then from there the sky's the limit. It won't be hard at all. Just make sure you have Python installed, pip installed, and Discord Pi. That'd be nice too.
And make sure all of it's updated.
Yes, make sure. But yeah, just all that, and that's it. You don't need to know any Python.
Thank you, Matt.
Matthew, you said
Oh, sorry.
so you said pip and discord.py, right?
Honestly, just have pip. I did this with a couple other guys as a practice run, and we spent like an hour figuring out why these guys don't have pip, even though they have the latest Python. So I don't have the luxury of doing that, obviously, at an actual workshop, a larger crowd. So anyone that plans on coming, and I'm sure we'll add it to the announcement, just make sure you have the latest Python and pip installed. And then from there, one command line to download Discord.
All right, thank you.
No problem.
That was a fun experience trying to figure out pip.
Dude, it's a pain, especially
That's
when things like
interesting. I know some Python